this integral might look like the most difficult integral in the world because it's hard to guess what's the first step. In order to understand what would be the first step, understand that denominator is a polynomial in x. In fact, also the numerator is a polynomial in x of power 0, and the denominator is the polynomial of power 4. Whenever the power of numerator is less than the power of denominator, always check the possibility of partial fractions, because that's the most probable answer to that integral. In this case, the power of numerator is less than the power of denominator. So it could be partial fractions. The thing that confirms whether if it's a partial fraction or not is whether denominator is in factors or is factorizable. In this case, can you factorize this x raised to 4 minus 1? I think you can. If you are able to factorize it, then definitely it is a partial fractions problem. Let's see if we can factorize that x to the power 4 minus 1. So what you can do is you can actually write this as x square minus 1 square. So let's try to convert it in terms of factors. If we were able to factorize it, we can do partial fractions easily. So we have integral of 1 over. This can be seen as a square minus b square. So it is a minus b and a plus b. So you can write it as x square minus 1 and x square plus 1. Okay. We can also further factor this x square minus 1. That x square minus 1 can be written as x minus 1, x plus 1, and you already have x square plus 1 with respect to x. I hope that makes sense. Now, since the denominator is in terms of factors, you can easily apply partial fractions here. Okay, so in order to apply partial fractions, what you do is you say let that whole function 1 over x minus 1, x plus 1, x square plus 1 be equal to a over x minus 1 plus b over the second term x plus 1. Okay, so a over the first term, b over the second term, plus the third term is x square plus 1. Now remember that whenever the term is a quadratic term, the numerator should be a linear term. Okay, so instead of just writing c here, which I would have written if it was a linear in the denominator, but since this is quadratic, I have to write a linear term. So I'll write cx plus d. Okay, I hope that makes sense. Remember that the difference of power between these two should always be 1. So if the power is 1, in the numerator power should be 0. Similarly here the power is 2, so in the numerator power should be 1. The difference in the power should always be 1. Okay, so since it's a quadratic, I write a linear term. If it was a cubic, I would have written a quadratic in the numerator. Okay, I hope that makes sense. Now, once we find the values of a, b, and c, it's a very easy integral at that point. So on the right hand side over here, you can just apply the basic addition LCM using the LCM rule. So what you have is you can write the first term. First, let's write the denominator. Okay, so the denominator is for sure the product x minus 1, x plus 1, x square plus 1. And in the numerator, you just write the first term a and the remaining two terms in the denominator. So x plus 1, x square plus 1. Similarly for b, the remaining two terms x minus 1 into x square plus 1, plus the third term is cx plus d. The remaining two terms is x minus 1 and x plus 1. So x minus 1, x plus 1. I hope that makes sense. Now what you can do is, if you see this denominator and this denominator, they can easily be cancelled from here. So what you will be left here is, therefore you have 1 is equal to the whole thing. You can write the way it is. So a into x plus 1, x square plus 1 plus b times x minus 1, x square plus 1 plus plus cx plus d times cx plus d times x minus 1 times x plus 1. Okay, now in order to find the values of a, b, and c, what you can do is just substitute some random values of x, as we always do. If you try to substitute some random values of x, choose the values which will make your calculations easier. So for example, if I put x is equal to 1, if I put x is equal to 1, what will happen is this term will become 0 because 1 minus 1 is 0. Even this will become 0 because here also 1 minus 1 is 0. Okay, so try to put x is equal to 1 first. That looks like the most simple thing to do. So if you put x is equal to 1, you have 1 on left hand side is equal to a times 1 plus 1 is 2. Again, 1 square plus 1 is also 2. And these terms will become 0 because 1 minus 1, and even here 1 minus 1 is 0. So therefore you have the value of a as 1 by 4. Okay. Now let's choose some other value of x. I think the best that looks easy to me is minus 1, because once you put minus 1, the first term will become 0, and the last term will become 0 because of this minus 1 plus 1. Okay, so let's put minus 1. So you have 1 is equal to, again this will become 0, minus 1 plus 1. This will become b times minus 1 minus 1 is minus 2. Minus 1 square is 1. 1 plus 1 is again 2. Okay, and this is again, this was 0. So you have the value of b as minus 1 by 4. Okay, remember here also we have two values, c and d. Let's see what other value of x we can put. Let's try to put x is equal to 0. That looks like the next best thing to do. So if you put x is equal to 0, on left hand side you have 1 is equal to 0 plus 1 is 1, 0 plus 1 is 1. So we have a times 1 times 1. Okay, if you put 0 here, 0 minus 1 is minus 1. So we have plus b times minus 1, and 0 plus 1 is 1. Okay, plus cx plus d. Remember x is 0, so this term will become 0. You have just d times 0 minus 1 is minus 1, 0 plus 1 is 1. Remember, we already know the values of a and b. So if you know the values of a and b, we can also substitute that. So we have therefore 1 is equal to, instead of a just write 1 by 4, minus, instead of b write minus 1 by 4. Remember, there was already minus here, which is why I have 2 minus, 1 for this b and 1 which was already there, which is why I have 2 minus, and I have minus d. Okay, so I have therefore 1 is equal to 1/4 plus 1/4, this will become plus, is half, minus d. So therefore that would give you d is equal to half minus 1, which is minus half. So that gives you the value of d. Okay, now the only value that is left is the value of c. In order to find the value of c, you can really put any random value now. There is no, just try to put a smaller number. We already have put 1, minus 1, 0. I think the best next smaller number I can think of is x is equal to 2. So let's put x is equal to 2. So if you put x is equal to 2, let's see how that equation will turn out to be. So you have 1 is equal to 2 plus 1 is 3, and 2 square. So let's write a times 2 plus 1 is 3. 2 square is 4 plus 1 is 5. Okay. Plus, remember to, we can also substitute the value of a directly. We know a is 1 by 4. So instead of a, let's just write 1 by 4. Okay. Plus b times, we know b is minus 4. Minus 1 by 4, sorry. So we have minus 1 by 4. 2 minus 1 is 1. 2 square is 4 plus 1 is 5. Okay, plus cx plus d. X is 2, so we have, let me write it in the next line, so we have some space. So we have 2 times c, okay, plus d is minus half, so here you can just write minus half, and x minus 1 and x plus 1. 2 minus 1 is 1, and 2 plus 1 is 3. Basically, now you have to just solve this equation to find the value of c. Let's see how quickly we can solve that. So this is 15 divided by 4. So 1 is equal to 15 divided by 4 minus 5 divided by 4 plus this 3 times 1 is 3. Just multiply that 3 inside. So we have 6c minus 3 by 2. Okay, since the denominators here are 4, let's just write that 3 by 2 as maybe 6 by 4. Okay, so you can basically like simplify that together. So 15 minus 5 is 10. 10 minus 6 is 4. And 4 divided by 4 is nothing but 1. So essentially those this term, this term, and this term is just giving you 1. Okay. So what you have is 1 is equal to 1 plus 6c. Okay. That 1 and 1 will get cancelled. You have 6c is equal to 0. That gives you c is equal to 0. So now we have the values of a, b, and c, and d. You can substitute all those values and your integral will then become, you can substitute everything here. So your integral will become a over x minus 1. So let's write that integral now. So let's say if it was I, if your integral was I, so integral will become a over x minus 1, I think it was, right? So a over, yeah. So a over x minus 1, b over x plus 1. So we have 1 by 4 over x minus 1 plus b over x plus 1. So b is minus 1 by 4. So b is minus 1 by 4. So we have minus 1 by 4 over x plus 1 plus we have cx plus d here. So c is 0. So we have 0x plus d. So 0x minus half over x square plus 1 with respect to x. So this is your integral after substituting the values of a, b, c, and d. Now what you can do is just split that integral in all of those terms. So this 0x is nothing but 0. So just give that integral to everything. So we have integral of, and take the constants out when you split the integral. So we have 1 by 4, 1 over x minus 1 dx, minus 1 by 4 integral of 1 over x plus 1, minus 1 by 2 integral of, don't forget to write dx, okay, 1 over x square plus 1 dx. Okay, remember that what I essentially did over here is just split that integral in all of those terms. So I give that integral to the first term, then I give that integral to the second term, then I give that integral to the third term. Okay, and I take the constants out. So I took 1 by 4 out, then I took minus 1 by 4 out, then this was essentially 0, and I took minus half out, and I have those terms. Now you can easily just find the values of those integrals. So you have 1 by 4. For integral of 1 over x minus 1, we know it is ln mod x minus 1 minus 1 by 4. For 1 over x plus 1, the integral is ln mod x plus 1 minus half. For this 1 over x square plus a square, remember the formula of integral of, we know integral of 1 over x square plus a square dx is 1 over a tan inverse of x by a. Remember this result, okay? So we can just apply that here. So we have 1 over 1 tan inverse of x over 1 plus, let's add the constant of integration c, and this is nothing but the final result of the integral that we are looking to solve. I know this was a little bit lengthy integral, but I hope it helped you to understand how the partial fractions could really make it easier to simplify polynomial divided by polynomial. If you understand this concept, please consider to like this video and subscribe to this channel. If you want to master calculus, don't forget to hit that subscribe button. I do post math and calculus content every single day. I'll see you tomorrow.